I didn't want to check the video this time because we got it.
All right, are we recording? Okay. All right, settle down, settle down. Guess I need the bloody microphone.
Yeah, use an emulator. And then same thing with
Test, test. 1, 2, 3. Do you have a question, sir? This is an excellent question. So for those of you who are just tuning in, test 3 is now canceled. So the question remains, what do we do with that 10%? It is either going to be one of two things, depending on which is more beneficial to your individual grade. Either those marks go to the tests that have already been written, or they go to the final exam. So that's how we're going to handle things. Yes?
If it goes back to like the test we've done, then like is it gonna like be our like greatest mark, like 1 or 2?
No.
No.
No, it'll be 15% instead of 10% for each of the tests. I'm not selecting the best test and giving you that. That's way too far, man. Come on. Yes?
when you mean it's going to be which is more beneficial, either it's transfer to test or either the final exam, like based on the individual or based on the class?
Based on the individual. Yeah, so that's how it's going. So, this class no longer has any TAs whatsoever. All 5 of them went on strike. So, expect diminishing services. Yes?
Never mind.
Okay. For me, I don't know, maybe people just really couldn't stand me and couldn't wait to go on strike and get away from me. But of my 13 TAs, 11 of them have gone on strike. 1 of them has stayed on, and 1 I hadn't heard from yet, so I imagine she's probably gone on strike too. She just, I guess answering emails from me is also TA work, so she's not doing it because she's on strike or something like that. I'm not sure. Some kind of situation like that, anyway. So basically, we've gone to emergency backup plan Omega, and basically I'm going to have to throw out everything that isn't nailed down. One of the things that is not nailed down is the exam, so the exam will still be occurring, of course. Since the assignments are auto-graded, the assignments will still be marked and graded using the auto-grader, although it'll probably be a lot longer lead time, so don't expect your marks back quickly. And I no longer have the option of considering regrade requests. So what you get from the auto grader is what you get, unfortunately. So, in addition, I probably won't have any time to help you with the work of the course either. So make some friends, because you're officially out in the cold. All right, and that's how this goes. And if you feel like this is not the education you're paying for, I would encourage you to direct a letter to the administration. So, yes.
Since this is not the education paper, do we get part of the refund?
Again, I'll let you take that up with the institution. Refund? Are you mad?
I said partially.
Partial? Well, don't you get it? Like, the university is a hole into which money flows. No money ever comes out of the hole. That's how these funding black holes work. You never get anything out of them. That's ridiculous. So, are there any questions about the New World Order? I recommend everybody develop some independent study habits quickly. So, moving right along then, we have, despite everything, we still do have some lecture material to cover, so I will still be performing those duties, as it were. So, we were talking about file, input, output, how to perform it, what to do with it, and other associated topics. Just quickly reviewing the stuff from last time. As you can tell, I'm still getting over the cold from last week. I'm not infectious, I swear. So, I think technically the map check policy is still in place, isn't it? Oh, it's like the COVID screening app. Yeah. I don't think they ever actually technically removed it. Anyway. So, file I/O. File I/O occurs through the generation of a file handle object. The file handle object contains all of the information necessary to read files from your system's file system. We live in interesting times because it used to be that a undergraduate entering a computer science program would have a reasonable knowledge of file systems, what they are and how they work. This was sort of, if you were a computer user, you had to use file systems. As technology has developed, I guess the use of a file system has been declared too advanced knowledge for the general computer user, particularly on smartphones, and it seems most people think that doodling around on a smartphone constitutes using a computer, which it doesn't. So many people don't actually even know what a file system is, but it's where all of the data that's kept on your computer in permanent storage is kept. So, at any rate, you create the file handle object by calling the open function. A file handle is the return result of open. You specify a file name using relative or absolute addressing in your file system. You specify a mode, putting the file in either read or write mode. In this class, we'll only really be concerned about read and write mode. You can read the entire contents of the file to memory using read. You can read it line by line using read line, and you always need to close the file handle using the close function. You can also use the with local binding to bind the return results of the open function to the file handle object The advantage of doing this is that it binds the file handle to the context of whatever is indented past the width. Once this indentation ends and you resume regular control flow, the file handle.close is automatically called at the end of the block, so you don't have to remember to do it manually. That's the advantage of the with clause. Make sense? So, if you're trying to open a file that doesn't exist, you will trip a file not found error. These errors can be caught using try except blocks in the manner that we have studied up to this point. So, having reviewed reading from files, let's examine writing to files. When we write to a file, we, aside from this R changing to a W, there is no actual syntactic difference between the way that you, use the with clause or use assignment to assign the file handle. The invocation itself is precisely the same in both cases. All you're doing is specifying a different mode. It's very important to note, putting things in write mode, this would be more accurately termed overwrite mode. All right? When you write a file, it clears the existing contents of that file, and anything you add to the file is new content, right? It deletes the old file, opens it up again, and anything the file will not contain anything that you have not written to it inside of this Python file, or inside this Python script. Make sense? If you want to preserve the contents of the file and add more things to the file, there's a different mode for that called append. You would put a little A here. Make sense? Good. So, your basic functions for writing to files, file handle dot write writes the string s to the file. You may notice the lack of a write line function here. Essentially, write is playing double duty, where in read mode, one invocation of read reads the entire file. You can either write everything you want into the file all at once using write. You would be separating new lines with the new line character, right? Or you can call write as many times as you wish, and if you call write multiple times, it will always write in at the end of the file that you're currently writing to. Make sense? This isn't too bad, right? Hopefully. Question? Yes?
As in the right, is it a string?
Yeah. That's some string, whatever string. The string that you want to write into the file. So, you can also do this with print. So, if you prefer print, if you have specific ways and you like some of the additional options that print provides, it's still possible to use the print function itself to write to a file. Incidentally, this is how print regularly works. It's just that the file that print regularly prints to is standard output, which is a system file that is redirected to the display that you're using when you're in a command line interface. This is how things work. You can redirect the print. You can redirect print to any file by specifying file equals the file handle that you're printing to. Right? So if you enjoy having the ability of print to print many comma separated things and separate them, modify the separation character or the end character or that sort of thing. If you like those options, You still have them available to you. And of course, in the same way as with reading from a file, when we are finished writing to a file, we call fh.close. Make sense? Any questions? Good. So, let's do an example then, shall we? Good. So, this file, as it currently exists, finds the topic3.py source code file, simply reads it to a variable called contents, and outputs that to standard output. That's all right. Topic9.py. So it goes. So let's imagine that we had some kind of very simple transformation that we wanted to apply, right? For example, let's say we wanted to change all of the, I may have done this example already, but let's imagine we just wanted to change all the lowercase letters to uppercase letters, or something like that, right? If I'm remembering this correctly, that's as easy as it is in Python. There we go. So calling the upper method on a string converts it to uppercase, right? So we now have a modification of the file. This modification is something we would now like to write into memory, right? So with open topic3_upper.i in write mode. Now the question is that the return result? Do I have to do? Probably I do, because strings are immutable. Contents is equal to contents.upper. File handle dot write contents, and there we go. Should be as simple as that. Oh, yeah, I forgot the as fh. There we go. So this operation was performed without incident. If I examine the files in the current directory, you'll see that topic3_upper has been created. If we view the contents of that file, it should surprise no one that the modifications exist in this new file. Make sense? Any questions about any of that? Yes?
What does cat stand for?
Cat means catalog. It's a Unix command which views the contents of a file. You'll learn all about it in 1xc3. Any other questions? Okay. So, again, it's possible to do this with print and by specifying the file handle as the file that we're printing it to. also possible to print to standard output without using print, although I can't imagine why you would ever need to do this, and I don't know why this slide is in the presentation. There we go. So, good. So let's talk about the internet now. So, here's the question of our age. What is the internet? Yes, sir?
A virtual network that's used to connect various networks and computer systems together to transfer information.
Yes. That long explanation. What the internet looks like from the perspective of a computer is a gigantic distributed file system, right? That's essentially the purpose of the internet. Like all of the networking, all of the nodes, all of the packet protocols, all of the infrastructure is to support treating other computers, treating all of the computers connected to the internet as if they had access to portions of every other computer's hard disk, right? This is kind of the model. So, for example, when you load a web page, what you're actually doing is you're sending a request out over the network requesting to access a particular file on a particular server. That packet either succeeds or fails. If it succeeds, the information contained in that file is returned to you. Now, that might also require additional packets to gather additional files which are used by the file that you've loaded, right? But it's just a file. That file is then taken by some piece of software, normally a web browser, but not necessarily a web browser, and it's interpreted. It is displayed, right? The file, all browsers are basically fancy file renderers, right? So, when we access internet data, the mechanisms by which we do so are very, very similar to how we would access a file on a local file system, right? It's a little bit more complicated because, it has to go out over a network, and it might take an indeterminate amount of time to receive the response, so you have to do an asynchronous communication with the outside world. Accessing things on your local file system is simpler, but in terms of the fundamental operational principle, accessing data from the internet is more or less the same thing as accessing it from a local file system. Make sense? So, reading data from the internet. Same idea as reading data from a file, except our file handle is the file handle of a remote resource rather than a local file. We'll use the URL lib module to open remote resources. So, here we go. Import URL lib.request. We give it a URL address encoded as a string. Notice that this is the full URL address, including HTTPS, right? One of the things that web browsers will do is allow you to abbreviate URL addresses somewhat. You don't get away with that. You don't have that type of luxury if you're just riding bareback on the internet. We receive response, so we send out our request. We request to open a remote source, right, by using urllib.request.urlopen and specifying the URL that we're trying to access. Notice that this is a text file that we're trying to access. So, Has anybody done any web development here? A little bit? So when you type in something like google.com, even though you're in Canada, are you accessing, like, is www.google.com, is that a file? What is it doing?
It's redirecting you quietly to /index.html.
Yes, absolutely. So even when you type in www.facebook.com, it's actually silently and secretly redirecting you to a file with a fixed specified file name. Everybody's agreed. Everybody has at this point agreed that if you just type in a URL but you leave off the file name itself, that redirects you to index.html in whatever folder you're accessing, right? That's why, like, you have all these slashes. It's a directory structure, right? So, so this is just accessing a regular text file that's formatted as a regular text file is formatted, right? Just a normal file. The only difference that might be there has it been encoded differently on the local file system that it's currently residing on, and do you need to decode it? Although most systems are now very solidly UTF-8 and Unicode and associated, big formats. The internet also has to deal with the problem that, systems that do not use these character sets may still be around, One might imagine, back in the days, way back, when the Soviet Union was still around, they probably wouldn't want to use Unicode or, ASCII encodings. They'd probably have their own encoding that would map, Cyrillic characters directly to the first numbers because, primacy of the, native language and all of these types of things, and we wouldn't want influence from Western imperialist character sets. So, you can imagine the trouble of trying to interface, a Soviet computer with an American computer, because the American computer is assuming all of, the characters that it's using, it's assuming they're all, according to ASCII. The same integer values will be transferred between one and the other, but those integer values will mean very different characters on the other end, right? So, back in the day, what you would do is you'd probably, have your spies steal an American or a Soviet computer or vice versa, and then put the file in there and see how it reads. And then you'd have to have the translator come in and actually translate it, and then you could get the secret spy data. But yeah, anyway. So we have these kinds of built-in mechanisms in the internet to, so that we are not assuming every computer system connected to the internet is using UTF-16, UTF-8, ASCII. Exotic character sets are permitted, shall we say. So, at any rate, the response packet will contain the results of that remote file access. So response.read functions in this way very much like filehandle.read, right? So, the problem though, if we actually examine this S, this string that has been given to us, it's not actually encoded in ASCII yet. It's printing because print will automatically interpret it as being encoded in ASCII, right? If you ask to see what the type of it is, it's actually encoded as binary information. So in Python, what that looks like is it's of class bytes. So we have a group of bytes rather than a group of characters. So we have to find some way of converting two characters from bytes. So, fortunately, one of the things that's built into the format of internet packets is they carry information about what character set is appropriate for them to be interpreted using, right? So the way that you extract that information from the response packet, response.info.get content character set. If this is not specified, or ASCII will put ASCII in the place of that missing information. So if that packet doesn't have anything that's put down for its character set, it's usually a pretty safe assumption to assume it's going to be ASCII, and it's usually pretty obvious if that's a bad assumption because you'll just get a bunch of garbled nonsense when you try to read or use the file. So once we have established which character set the response packet is encoded with, we can decode the response by adding the decode method to the results of response.read and specifying the character set which we found by reading the packet information. Make sense? Good. So, if you want to read this information line by line, and this is something that works for other file handle, like a regular local file handle as well, response, the response packet class, has a definition for iterable. In Python's class system, if you have a definition for iterable is what the for loop uses to loop through the items in a thing. So lists have a definition for iterable. Sets have a definition for iterable. Any customized class that you come up with can be used by for loops so long as you define what iteration means for that class, right? So, file handles are iterable. To iterate over a file handle is to read each line in the file subsequently. Response packets are the same. If you want to read each line in a remote file line by line, you can plunk that thing in a for loop. Make sense? Question?
What are some specific examples of character set?
You mean non-ASCII character sets?
Yeah.
Wikipedia. I'm sure Wikipedia has some. I don't know. The reason I invent a fictitious Soviet character set is because I'm not that familiar with them. I'm very firmly entrenched in ASCII and Unicode. So, one final note on accessing remote sources. In the same way that we get a file not found error if we try to open a file that does not exist on a local file system, we get an HTTP error if we try to access something that doesn't exist on a remote file system. And you can, of course, handle that error in precisely the manner that you would expect using try except. HTTP error and associated errors, that's slightly more general than the file not found error. My impression would be that if you ended up with like a 404, like this This is the same thing as a 404 error in this example, right? 404, page not found on GitHub. This is not the page you were looking for, sort of thing, you know. There are a lot of different errors on the internet. 403 error is forbidden. If you ever get 403 forbidden, it means that you've tried to access a file that's not publicly accessible, right? Or a directory that's not publicly accessible. So I'm not sure whether that would load on HTTP error in Python or not, but I suspect that it would. If I had to guess, they're probably using HTTP error as a general base class of errors, and then, you know, all of the specific internet errors would inherit from that base class. So that would be my, you know, that would be my conjecture, shall we say. Any questions about the internet? Okay. Moving right along then. So, if I were to catch any of you doing that, I'll slap you silly.
Is for schoolwork.
I don't care if it's for schoolwork. It's defacing the bloody artifices, you know. Like, have more respect for the institution than this, please. So, file formats. So we know how to access files. The question remains, what types of files can we access? It need not be said that there are basically as many types of file formats as there are programs which access them. There is a very, very, very large number of file formats. Some of them are standardized, most of them are not, right? We'll be talking about 2 standardized ones and one that's not standardized. The concept of a file format is somewhat ephemeral. File formats, from one perspective, don't really exist. They are not a property of the file, right? All files are encoded in either characters or binary code, right? That is the only 2 distinctions. That's the 2 ways in which files are formatted from an individual character perspective. The operating system doesn't really care, right? Whether or not a file is in the correct format is entirely dependent on the program which reads it, right? If a program expects a file to be organized in a particular manner, and it's not, that program's going to trip an error, right? The file extension itself is primarily for the benefit of programs expecting files in particular formats. There's nothing, like there's no operating system, you know, automatic subroutine that's kicking files in the pants for not having, you know, internal formats that match their external file extensions, right? You can take a JSON and you can call it a .csv file. This is a perfectly legal operation. Anything that's expecting a CSV file will, of course, trip an error if it's actually reading JSON instead of a CSV file. Some programs are smart enough to ignore the file extension and recognize JSON data when they're dealing with it. It depends on the programmer who wrote the program, right? I just want to, like, enforce that because, you know, it's very liberating to know that you, too, can invent your own file extensions for programs that you write, right? You know, this is extremely common, you know, for the sake of argument. video game save systems, right? A lot of the time, they'll sort of default to something like .sav, right? But more often than you'd think, they default to some kind of interesting, strange file extension just because it's kind of fun to invent them, you know? Like, I think, like Civ 4 games, the save files on them are .siv4, and like there's nothing constraining the number of characters in a file extension. There's nothing even constraining the number of file extensions a file may have. A file may have any number of file extensions. So, a file extension, all that means is that there's a period in the file name, and after that point, that's some series of characters that's meant to distinguish this file as being readable by certain programs. The operating system will look at the file name, and on the basis of those characters after the period, it will automatically reroute you to one of a list of appropriate programs for that file extension, if it thinks that you've activated the file to open it in some way. Does that make sense? Yes?
Doom uses a format called .wad, which means where's all the data.
Sorry?
Doom uses a format called .wad, which basically stands for where's all the data.
There you go. .y for Doom save files.
.wad.
Oh,
W-A-D, where's all the data.
.wad. That's funnier. Sorry, my hearing. So, in this class, we're going to focus on some of the common file formats which are used for the exchange of data between programs that have been written by programmers, if that makes sense. Instead of, like, we're not going to focus on talking about, Word files or Excel files, although, incidentally, basically, all Microsoft Office documents, like, under the hood are XML-based, so that's another reason why Microsoft sucks, because XML also sucks quite hard. XML sucks, the big one, if you've ever tried to work with it. So we're going to talk about CSV files, which are comma-separated value files, essentially a form of plain text spreadsheet with no formulas. We're going to talk about JavaScript object notation, which is it was originally a way of communicating object information between different JavaScript programs, but has since sort of morphed and become a very general format for nested lists and dictionaries, right? Anywhere you can describe data as a list of dictionaries or I'm messing up words, but you guys know what I mean. We'll see what it looks like. We're also going to talk about YAML. YAML stands for yet another markup language, and it is essentially the new form of JSON that all the cool kids are using these days. We'll talk about that briefly, and that will be sufficient for file formats for us. So, very briefly, because we don't have much time left in class. Comma-separated values. How many people have seen or used a CSV file before? That's more than I was expecting. Excellent. CSV files are commonly used for importing or exporting spreadsheets between applications. Not just applications, often web applications as well. When I perform the big grade dump at the end of the semester, that is to say, when I take the grades off of Avenue and I put them into the system in Mosaic, the file which is the intermediary for that process is a CSV file. and the file that gets the grades off of Jupyter and into Avenue is also a CSV file. So these are actually used in practice for, you know, many, many, many types of operations. For example, okay, so you guys want to hear how horrible Mosaic is? All right, you want to know how it actually encodes your grades? Like when I enter the grades, how it's being encoded? It's an enumeration. Yeah, it's an enumerated list containing all of the numbers between 0 and 100, including like A, B, D, all of the letter grades at the end, as well as like incomplete, and like every possible thing your grade can be is in a huge like scroll through drop down list if I click through on Mosaic. Right? That some of you, I can see some sour faces. So one of the consequences of this, right? I cannot import your grades as floating point data into Mosaic. Yeah. It's reading it as bloody strings, and it can't have a decimal point. Because, you know, to include 2 decimal points would mean that the drop-down list would be, you know, 13.01, this is 13.02, this is 13.03.
So does it round before?
Hmm?
Does it round before?
No, it doesn't round. If you don't provide a string, it doesn't. It won't take the data. It'll fail on an error. Like if the data that you give it contains a decimal point, it fails on an error. So I have a nice little Python script which takes your floating point data, which is the native representation inside of Avenue, rounds it, and then, how do I, it's just regular rounding. Actually, if you can find a way to trick Python's round function, then you might be able to trick the way that your grades are rounded. But, if you have a sufficient degree of mastery over the system to be able to get your grade to 58.953 or whatever number would do that, then kudos to you. But I have a script that rounds the grade, expresses it as a string with no decimal point. Oh, no, it's interesting though, actually. If it can be a decimal point so long as it's 0.0. But everything else, it'll just be an error. Like the first time I ran this, I ran the grades and I got 287 errors. And then it was I looked through the data and it's but this did read about 3. And it's 3 students in the class have dead even grades. And it's So yeah. Yeah, we're done.